Hello, and welcome to Backer Breaks It Down. In this episode, we are going to explore angles formed by parallel lines. So, we're talking about the pairs of angles formed by a transversal cutting parallel lines. Now, you did a construction and you constructed corresponding angles. Now, corresponding angles, one is on the inside, one is on the outside, both are on the same side, and they're not adjacent. So in this diagram here, corresponding angles would be like angles 1 and 5, 2 and 6, 3 and 7, 4 and 8. You also have alternate exterior angles like 1 and 8, alternate interior angles like 3 and 6, same side interior angles like 3 and 5, and same side exterior angles like 1 and 7. Now, these angles are either going to be congruent or supplementary. So let's see what's what. Now, in the construction, you made corresponding angles, which you know to be congruent since you copied an angle to construct the parallel lines. In the diagram at the right, the corresponding angles would be represented by the given 55-degree angle and angle 7. So that means angle 7 is also 55 degrees. So use what you know about vertical angles and linear pairs to find the measures of the remaining angles. Well, I know that angle 1 would also be 55 degrees because vertical angles are congruent. Likewise, angles 5 and 7 are vertical angles, so they're congruent. But what about angles 2, 4, 6, and 8? What are their measures? Well, angles 1 and 2 form a linear pair. So that means that they are supplementary, which means they add up to be 180. So that means angle 2 would be 125 degrees. It's vertical to angle 4, so it's also 125 degrees. I've got another linear pair with angles 5 and 6. So 6 would be 125 degrees. And angle 8 would be 125 degrees. So let's summarize this. Okay, if two parallel lines are cut by a transversal, then any pair of the angles formed are either congruent or supplementary. So our congruent angle pairs would be the corresponding angles, the alternate interior angles, and the alternate exterior angles. Let me go back to that diagram. So like angles 1 and 7 are alternate exterior angles, and they're both 55 degrees. Angles 2 and 8 are alternate interior angles, and they're both 125 degrees. Now, the other two angle pairs are supplementary, same side interior and same side exterior angles. So like angle 2 and angle 5, 125 and 55 add up to be 180. So they're supplementary. Same with 4 and 7. Those are same side exterior angles, and they're supplementary. So let's find some angle measures. So in problem number 2, we want to find the measure of angle 8, GHI. Okay, you see where angle GHI is? It's like a crook angle. So I'm going to draw another parallel line. So this line is parallel to A, B, and C, D. And so since it's parallel, it's creating some of those angle pairs that we just discussed. So like this little angle right here, what would be its measure? Yeah, it'd be 40 degrees because it's congruent to angle AEH. So this angle's 40. And what about the adjacent angle right next to it? Well, if this angle is 70, then this angle right here is also 70. Now we just need to add 40 plus 70 together, and we'll get the measure of GHI. So GHI is 110 degrees. We're given that M is parallel to N. We want to find X. Well, right here, I've got a pair of vertical angles, correct? So that means this angle right here would be 80 degrees because vertical angles are congruent. So what about that 30-degree angle? It is an interior angle. This angle right here is also an interior angle. These angles are on alternate sides of the transversal. So they're alternate interior, which are congruent. And then we have a triangle. And what do you know about all three angles in a triangle? That's right, they add up to be 180. So like these two angles here add up to be 110. If we subtract that from 180, we get 70, and that is the measure of x. Given that L is parallel to M, find x. That makes sense. Well, if L is parallel to M, that means that these two angles right here are same side interior angles. And same side interior angles are supplementary. So x squared plus 9x minus 10 equals 180. So getting this equal to 0, we have that x squared plus 9x minus 190 is equal to 0. So now we have to factor this. So we have to think, what multiplies to be negative 190 that adds to be 9? Well, 19 times 10 is 190. If the 10 is negative, I'm going to get positive 9 when added together. So we're looking at x plus 19 and x minus 10 is equal to 0. So algebraically, there are two solutions. We have that x is equal to negative 19, or it's equal to 10. Well, like the problem says, find the value of x that makes sense. So can x be negative? And the answer is no. If x is negative, then 9x minus 10 is negative. So the answer that makes sense is the positive 10. Given that L is parallel to M and the measure of angle 2 is 3x plus 17, and the measure of angle 3 is 5x minus 21, find the measure of angle 1. Well, angles 2 and 3 form a linear pair, and as you know, linear pairs are supplementary. So if I add those together, I get 8x minus 4 is equal to 180. So if I do some algebra here, I get that 8x is equal to 184. And if I divide, I get that x is equal to 23. Now I want to find the measure of angle 1. I know that angle 1 and angle 2 are corresponding angles. And corresponding angles are congruent, right? So if I go 3 times 23 plus 17, I get 86 degrees. And that would be the measure of angle 1. Find the value of the variables in each figure. Well, x is going to be easy because we know that this angle here is 106 degrees. So what's the relationship with x? Same side interior. And when you have those same siders, same side sup. So x is going to be equal to 74 degrees. So what's the relationship between the 2y and the 106? They are supplementary. They form a linear pair. So therefore, I know that 2y also is equal to 74. And if I do some dividing, I get that y is equal to 37. So what is going on with 4z plus 6? What can you tell me there? Well, we know that this angle right here would also be 74 degrees, right? And we know that these two angles are same side interior angles. So that means they are supplementary. So 4z plus 6 plus 74 would be equal to 180. So if I do some algebra, I get that 4z is equal to 100, and thus z is equal to 25. And then in our last problem here, we want to find the values of x, y, and z. So what do you see going on here? That's right, I see a straight angle, and straight angles are 180 degrees. So we've got 3x plus 90 is equal to 180. And if we do some algebra, we get 3x is equal to 90. Thus, x is equal to 30. So what else is equal to 30 degrees? If you said the 2y would be equal to 30 degrees, you are correct, because right here we have alternate interior angles, and alternate interior angles are congruent. So 2y is equal to 30, which means that y is equal to 15. And then what about z? You see a relationship with z? That's right. This angle x and this angle z are same side interior angles. Same side, sup. So z plus 30 is equal to 180, which means z is equal to 150. So, as I mentioned earlier, if two parallel lines are cut by a transversal, then any pair of angles formed are either congruent or supplementary. Your congruent angle pairs are corresponding alternate interior and alternate exterior, and your supplementary angle pair are those same side sup ones, same side interior and same side exterior. And that's how Backer breaks it down.